All right, welcome. One of my students asked me to solve this, so let me quickly do it here. So, okay, they say find the resultant of the forces along OB in the diagram. So we have one force acting this way, 60 Newton, and we have another force acting this way, 80 Newton, and the angle between the two vectors is 120 degrees. So we are to find the resultant effect of those two vectors. So there are two ways we can do this. Number one, we can do it using laws of parallelogram laws of vector resolution of vectors. Laws of, how do I explain it? Parallelogram law. We can use parallelogram law to solve this, or we use vector resolution to also solve this. And if you ask me, I'll tell you the better one to use is vector resolution. But I'm going to do the two so that you understand how to you understand the two. So first, let me use parallelogram law. Parallelogram law says if you have two vectors acting on a body or acting at a point, that their resultant can be represented in magnitude by the diagonal of the parallelogram formed by the vectors. So these are two vectors, and then what kind of parallelogram have they formed? I'm going to sketch. So if you draw a parallel line to this vector 60 Newton, you find out that and also draw another parallel line to this vector 80 Newton, you find out that you formed a parallelogram. This is a parallelogram. The sides are equal. The opposite sides are equal. Okay. So now, law of parallelogram says that the resultant of the two vectors will be represented by the diagonal of the parallelogram. The diagonal is not from here to here. That is wrong. The diagonal is from here to here. Okay, let me draw that correctly. From here to here. That is the diagonal we are talking about. The diagonal is the one that bisects the angle between the two vectors. So the diagonal we are talking about is the diagonal that bisects the angle between the two vectors. Okay, so we write here our R, the resultant. So now, if here is 120 for parallelogram, we know that the opposite sides, the angle of the opposite sides are equal. So if here is 120, that means from here to here is also 120. Okay? So how do we find these other angles here? So we'll find it by doing simple geometrical distinction. The sum of the interior angle of a parallelogram is 360. It's 360. So here is 120, here is 120. 120 plus 120 is 240. So if we do 360 minus 240, 360 minus 240, this is 0. 6 minus 4 is 2. And 3 minus 1, okay, is 120. Now, that means this 120 is what is left to share between this place and this place. And since here and here are the same, so that means 120 divided by 2 will give us 60. So this place is 60 degrees. While this place is what? 60 degrees. This is simply geometry of a parallelogram. So we have gotten this place that is 60 degrees. We cannot use this 120 because we don't know how it is being bisected by this diagonal. You understand? So you don't just guess and begin to say bisected 60, 60. No, you don't know, you don't know. So we will use this one that we've proven with our theorems. So now I know this angle and I know this line, and what is left is this line. This R is what I want to find. So we're going to use a cosine rule to find that. Cosine rule says that the this side you are looking for, the square of that side equals to what? The square of that side equals to what? You first start with 80 Newton, the square of this side plus the square of this side. This side is parallel to this side, so here is also 60 Newton plus 60 squared minus 2 cos, sorry, it's not minus 2 cos that, minus 2 times 80 times 60. Then we now have cos what? The angle that is opposite to the side you are looking for. The side I'm looking for is R. So the angle opposite to that side is 60. So if you do this math, 8 times 8 is 64. Let me not waste time with this. If you do this math and later make R the subject of the formula, R equals to square root of whatever you've calculated here, you end up having your answer will be option C. Your answer will be this option C here. Okay. So if you use this cosine rule and evaluate this, find the square root, you find your answer there. So let's use vector resolution to solve this one now. So using a vector resolution, which is the one I prefer, easier one. Using vector resolution, so we are going to resolve the vectors into their components. I'm not going to resolve this 80 Newton because 80 Newton is directly on the horizontal, this thing. So it's only this 60 Newton I'm going to resolve into its vertical and horizontal components because it's acting at a certain angle. It doesn't fall directly on vertical and it doesn't fall directly on horizontal. So the angle this 60 Newton makes with the horizontal is 180 minus 120. You know, angle on a straight line, that's angle from here to here, is 180. So if you minus this 120 from it, it will give you angle here. So this is 60 degrees. Okay. So let's resolve this 60 degrees. So let's find. So the total vertical component B subscript Y will be, if you resolve this 60 Newton into a vertical component, that will be 60 sine, that will be 60 sine 60, which equals to 60, sine 60 is a square root of 3 over 2. And 2 will cancel 60. You have 30 root 3. Now, there's no other vertical vector that will add or subtract to that. Okay, so this is all we have for our vertical component. So for our horizontal component, V subscript X, okay, so we resolve this 60 into its horizontal component. That will be 60 cos 60. Now, this 60 ohm is acting on the left side. That's the opposite side of that of 80, while 80 is acting on the right side. So their resultant will be a subtraction. So 60 minus that, 60 cos 60 minus 80. Or you say 80 minus that. Okay? So this will give you, because 60 is half. So you have 60 times 1 over 2 minus 80. So that will give you a 30 minus 80, which will give you minus 50 Newton. Now this negative sign here means that the actual direction is towards the right, not towards the left. Okay? That's the resultant of the sum of the horizontal components is actually towards the right, not towards the left. Okay? Okay, so that's that. So we have find it. So we now, so here is now 50 Newton, and here is now 30 square root of 3 Newton. So the resultant is given as a line drawn from in between the two vectors. Here is the angle. So this resultant R. So this resultant R is gotten using Pythagoras theorem. So if you do 50 squared plus 30 root 3 squared, if you evaluate that, your answer will be C. Your answer will still be this option C. All right. So we stop there. Thank you. Mm.